mute yourself just for that background noise. Great. So do you think we should get started now, Trent? Awesome. Thank you everyone for joining. We have Ariel from the Graph who's going to show us how to build subgraphs so you can integrate them into your hacks. Thanks, Ariel. I'll let you take it away.
Thank you. Well, first with introductions, my name is Ariel. I'm working as a smart contract lead in the Graph. I joined the team a year ago. And previously, I worked for a couple of years in Decentraland, another project in the ecosystem. And I want to give you some tools that I think will be very helpful with the projects you're building. But also, I would like to use this opportunity to explain the value behind the graph and what is useful. I want to show you the different approaches when building a front-end application for something based in Ethereum on any blockchain, and the difficulties that you face when building that type of application, and what happened in Decentraland, for instance, so you can understand how you can implement in your project, basically using the graph. The idea behind the graph as a vision is to be an open API for all type of data. Basically, what the graph is doing is indexing blockchain data now, mostly the most popularly Ethereum, and it's organizing this information so you can query it easily. Okay, and the challenges you see when you are building a front-end application is that you have some contract, you created a protocol, and then you want to create a front end that is querying this contract, and it's hard for different reasons. Let me share my screen now so I can show you an example application. This is the marketplace that we built in Decentraland a few years ago. This is an improved version of the initial marketplace. But with the team, when we started creating a front end for our contracts, we faced many issues. The first issue is Decentraland was, well, it's an open virtual world with parcels of lands that people can buy and sell and put content on top of that. And we have all this information in contracts. The land is an NFT. You have mana, there is a token, and we wanted to build a front end. And the naive solution was to query the contracts directly, basically creating a React application, sending requests to an Ethereum node, and trying to print the information in the front end to help users. But it was a naive and a very slow solution, because when we wanted to show a map like this one, we needed to query thousands of land from a contract, and Ethereum nodes are not prepared for that. It's super slow. We found out that the information in the blockchain, the information is stored as blocks, it's stored as transactions with a payload, raw data, emits events, but that's not a proper or very friendly structure to query the data you have in your application. So what we did was to index that information doing our own manual TypeScript app that basically listen for events, Ethereum events, insert that information in a Postgres so we can query that information from our front end. That was much faster. It was a really interesting solution. But the issue with that is that maintaining a TypeScript or Rust or Go application that you build yourself for indexing the blockchain is tough. There are many things that can happen, like Ethereum nodes going down, maybe latency or some problem with the request. You have reorgs. You have to keep up with a lot of things. So in the end, we turned out migrating to the graph. Basically, the graph is is building, we are building a server called GraphNode that integrates, like connects what happens in the blockchain, your own indexer that is configured as mappings, and it exposes an API using GraphQL. So in summary, it's like a backend for your Ethereum application. Now, I'm saying Ethereum because it's the most popular, but there are like many different blockchains integrated. So the solution that now you see here in Decentraland is using the graph as a backend, and it's super fast. You can see that you can basically switch from different parcel of land fast, and it's querying the backend using the graph. So that's an introduction. I think that you can use the same thing in your project, and I want to show you what's behind the scenes to create something like this. An interesting place, I will say, if you want to start your create a subgraph that you can use as a backend, is to go to the documentation in the graph docs. You have the introduction explaining what you are building, but you have like a quick start where you can see like all the steps you need to do to bootstrap your project first. And then how to deploy the subgraph into our hosted service. Basically, what we are doing is running different nodes that we call the hosted service that accept different subgraph and index them and publish an API that you can use in the front end. Okay. So the first steps that you need to do is to install this package. You can use npm or yarn, the one you prefer, and it's going to install a tool that you can use from the command line called Graph. And by using this tool, you can bootstrap the project first. Okay, so it will create like a skeleton in a folder where you will work and then publish to the hosted service. Okay. I'm going to tell you more about something called the decentralized network that we launched in December. But first, let's focus on the hosted service. So the first steps to create a subgraph is to do the init that I mentioned. I have already created a project here, so I can show you with more information. But basically, what you need to do is graph init. You're going to connect to our service with GitHub. So I'm using my GitHub username and a name, let's say fake token. It's going to guide through the creation of this skeleton of the project. It's going to ask a couple of questions. You can select the blockchain you are going to index.
Hey, Ariel.
You can, yeah.
Can you zoom in your terminal a little bit?
Oh, yeah. It is better. Can you see that?
Yeah, I think that's better.
Okay. Maybe this. It's going to ask a contract address, and it's going to fill a lot of files by doing this. So I'm going to cancel and go to the project I already created. Here is the project. You can see like there are a number of files created by the Bootstraps script, and I'm going to explain each of the files so you understand what you need to do with each of them. So these indexing units is what we call subgraphs. So probably your project will have one subgraph at least, but it can have multiple subgraphs. Okay, so a subgraph is something that is connecting a blockchain like Ethereum. It's going to connect entities that we can think of entities like a table or an object in a database, and it's going to connect mappings or handlers. that you will use to map information from what you see in transactions, in blocks, or in events. You're going to map them into entities. Okay. So basically, you are transforming the data you see in the blockchain to something that is more of friendly for your application. Okay. So let's skip this part of the documentation that is about the init that I already showed. You have this file called subgraph YAML. Okay, that is going to define something that we call the mappings. So this is the same file in my project. You will see that these files configures a number of things. The first thing is a data source. We are saying I want to index the graph token. This is my example. We are going to index the graph token. It's a typical ERC20 token. We are going to use the mainnet, the mainnet network. The source, the address of this token is this one. We are going to start indexing everything that happens in the blockchain with the graph token from this block. You can leave it 0 if you don't know. You can like set to a particular block number if you know when this token or contract was deployed. It's more efficient if you set a block, so the graph node don't need to index from scratch from the genesis. So this will help. And then you define a number of mappings, what we call mappings. This is connecting an event signature. I'm using an event handler here with a function, okay, with a function called handle transfer. So when you run this subgraph, it's going to index every event with this signature by calling this function, okay, called handle transfer. So this is the mappings. You could define, let's say, if you wanted to manage more events like approvals, you will basically copy this information, paste it, and set the right signatures, like whatever it is. It could be any type of event emitted in a contract in Ethereum. So let's see the other part of this. You have a mapping configure. You have as I mentioned, an event handler, and there are some entities, as I mentioned before. For this project, I created one entity called account. What I'm trying to do here, this is an easy example, is to have a list of accounts that use the protocol, basically the graph token, and be able to query the balance of each account easily. Okay, so what I did is I created an entity, and that is defining schema.graphql, this file. Very simple entity. You define an entity like this. Type account is the name of the entity. This is the type. And as you see, this entity has two fields. One is the ID. This is mandatory. Every entity needs to have an ID. And one extra attribute that is the balance, okay? And this is a big int. Reference about how to define schema. You can like find information in Google everywhere about GraphQL. GraphQL is a protocol created, I think, by Facebook, where it can let you basically create an API on top of a model that you can query in different ways. Okay, so this is a way to define a super simple entity in GraphQL, and we are using GraphQL as a way to express and to query the API that you index. So here I have my account. And the last thing I need to do is to set the logic for the indexing, right? So again, going back, I have the mappings. I have an entity called account. I have an event handler from Ethereum every time the indexer see transfer, will call handle transfer. This function is on the mappings file. So you have these mapping files with a bunch of functions. This can be commented out. I'm not using them. They are empty. But you can see here is a file that it's in, looks similar to TypeScript, is assembly script. It's very similar to TypeScript with some limitations. And the good thing, this is compiling to WebAssembly, and it's super fast. So we have indexers written in Rust that can run these mappings in WebAssembly, and we've like tried to use the faster technology, and also Rust is very stable. So running basically one graph node is super safe. So
quick question.
Yeah.
One of the hackers is asking if there's a repo they can follow along with.
Good idea to have a repo. We have a repo, not for the project I'm doing right now, but there are like multiple examples of subgraphs. If you go to GitHub Graph Protocols, there are an example subgraph, and there are other subgraphs for, let's say, pull together, Uniswap, Aragon, and their own. And these projects also have subgraphs, so you can see the same structure.
Okay, yeah, that might be a good start. I'll grab those links.
Yeah, maybe you can look at example subgraph. What I'm going to do after the call is to maybe push my example so you can see it. Okay. So I was saying, okay, when the graph node is indexing the blockchain and is finding an event emitted for a transfer, it's going to call this function. And basically, I'm in charge of defining what this function should do. Okay, so what I'm doing here is we receive the event, and you can see that this is already pre-filled with some TypeScript bindings, so you can like see all the information you can basically read from the event. The address of the contract, the block, the transaction, to get like a hash, for instance. You can get the event parameters by doing this with from, to, and the value. And what I'm doing here is like fetching this information and basically then storing in the entity that I defined, okay, in the GraphQL schema. So this is basically some checks I added, because when you are minting a token, basically it's a transfer from the zero address, and I don't want to record an entity for the zero address, so I'm skipping that. But what I'm doing basically is storing one entity for the from account, storing one entity to the destination account, and subtracting the value from the balance of the source account and adding the value to the destination account. So I'm keeping the balances of multiple different accounts using the transfers information. Okay, so after the graph node finished indexing this subgraph, I will have information about the accounts with the proper balances. Okay. You can also, apart from writing, I heard some noise. Sorry. Apart from defining a handler like I'm showing you here, you can define other functions, helper functions. So for instance, I define this load or create account function that you can use from your own code. That is basically testing if the entity exists or not, and initializing a new one. Okay. You can again, you can think of an entity as an object that you save in a database, or a row in a table. Okay. So I want to show you a bit this function because it's interesting. This is the way I can work with entities. You will import in this file from the schema. I'm importing this entity I defined here. Once I import it, I can use it the same thing with this TypeScript bindings. So I can call functions like load that is going to fetch an entity from the storage using the ID. In my case, the ID is the address. Okay, the address of the account, and you can assign it to a variable, and then interact with that variable. Okay, so you can see the attributes to be defined. In my case, it's balance, and you can operate on that attribute. Okay, this is one way to operate with the entities. The other way is to basically I'm loading here. I'm testing if the entity is already there. The other thing you can do in this case is I'm testing if the account exists or not. If it doesn't, I basically create a new entity called account with the address and setting the balance to 0. Okay. The last thing you do after you basically operate on an entity is saving it, and it's going to basically save to the storage, update it, or create a new record. Okay. I find it quite easy. Maybe it's a lot of information when you see it like for the first time, but it gives you a way to like manage each of the events that gets emitted into a very contained function where you can like do transformations on the entities. So this is on the side of coding it. Let me show you about the workflow. So I'll move this down. You have the project here. When you need the project, it will create this package JSON with some information about the to deploy the project in our hosted service, but also some helper functions to basically build the subgraph. You'll see that there are two things, like you see code gen and build. And these two things are important. If you run code gen, this is basically is reading the schema, is reading the contracts information, and it's creating these bindings that I show you, where you can like basically import it in your code and do this and use it like a TypeScript object. Okay, so it will help with the development. You can see the generated files here, like graph token TS. This is auto-generated by CodeGen. And it's also creating this schema TS from the original definition I created here. Okay. You don't need to worry that much about these two generated files. You need to define the schema properly, and then basically run CodeGen if you change the schema. Okay. The other thing is building the subgraph. Well, my cat is trying to code with me. The other thing that you can run is build. It's the other important function in your workflow. Basically, what this is doing is compiling this, compiling your project into WebAssembly, and it's preparing it to being deployed. Okay, so running build is a good opportunity to fetch to identify issues in the code. Let's say I know. Let's do something. Let me see if this is breaking the code. Okay, I've removed some attribute here, and it's like giving me some information that the conversion is wrong, and I require a typecast. And this is because I'm like assigning something. I'm assigning a parameter instead of the attribute. So if you fix it and run again, you'll see a confirmation that the code is right. So you are able to deploy it. Okay. So this is all the things that you need to do to prepare your code. Handle transfer is a function basically I use for keeping track of the balances, but in your case could be something completely different. Maybe you are tracking NFTs. You want to track the I don't know, the rewards assigned on a farming DeFi project. There are many things that you can do. All these protocols emits events. You multiple contracts in the mappings. I set this data source, the graph token, but you can set multiple different ones. You can track multiple events. You have block handlers. You have many different tools to play and to create subgraphs. So the final step is to deploy this into our hosted service. If you want to do that, you can visit the Graph Explorer. This is the website of the hosted service. What we are seeing now here is my already deployed project. I already been playing with this example and deploying it. So you can see like all the information about the project, but you will sign in with your GitHub. Click Add Subgraph, and basically you can define you can put an avatar, you can set a name. Well, it's going to validate. It's under my account. You can set a title. You can decide if you want to show it or not in our Explorer. We have a dashboard where you can see all the subgraphs from different projects, and then you click Create Subgraph from here. And it's not working. I don't know why. Oh, there. So I created my new subgraph, and what you can do is follow these instructions. Basically, it's guiding through what we already did, setting a graph out, like you are using your access token to log in, and then graph deploy. Okay, so we are now going to do a graph deploy on my graph token project here. npm run graph run deploy. It is now building a WebAssembly, and it's going to push this subgraph to IPFS, and then notify the hosted service that it needs to index this subgraph. Okay, you get a confirmation that everything is all right. One particular thing to notice is that we are using IPFS. The graph node is using deterministic sources for all the information. Like if you run two subgraphs multiple times, it should like get to the same result. Basically, using the graph node is taking care of the block reorgs, and it's deterministic. So by using IPFS, we guarantee that the hashes won't change and the information is the same if you are going to index this subgraph from different places. Okay. So now if we go back to the UI, you will see the current version of the subgraph. and something called the pending version. Okay, the pending version is the new version I deployed, and the current version is like the live version I had before. And this is interesting because if you do change in the subgraph, let's say you fix a bug, or maybe you added a new feature to the subgraph, the current version will still be working. So your front end, if it's querying this subgraph, will keep solving the results and getting information from the API, and it's changed and hot swapped when it finished. Okay, so if you change to pending version, you will see the progress of the indexing. You can see like well, the hash of the file. You can see a log of the progress of the indexing process. You can see like things like this signature here. It's calling handle transfer. You can change the debug level, and it's good to see the progress. It's also showing the progress here. Okay. So this hosted service helps like a playground where you can submit your subgraph, test it, share this link where people can start using this subgraph, integrating in a front end or on any other service. Let's see this playground first. We have as you know, we define this account entity, these two attributes. I can query it by using GraphQL. If you click play here, you'll see account data. Like for instance, this account has like 0 balance. This one way of token. This account has like more balance. Remember that this number is in way, so it's a super long number. You need to divide to take into account the decimals in the token. You can change this to query more results. This is a very simple example, right? But it gives you an idea of the workflow. Things that you might need when developing a subgraph is adding some debugging information, like where is that here? Let's say you want to log let's say you want to add some logs to your handler. You can import this GraphTS library and use the log function. So you could add things like log debug, a message, a placeholder, and then something to fill this placeholder. Let's say it's from, okay. So when you build this project and deploy, you will see this message in the log. Okay, this is very useful if you want to see if a variable has what you expected it to have, for instance. So let's deploy the project again. It's going to generate the files. If the files change, the IPFS hash will be different because the content changed. So it will be a different subgraph. And now it's deploying. So we get back here. And we can see that this subgraph ID match with the hosted service one. So we know that we are indexing the right one. And then if we go to logs, and we set debug level, we can see the message I set in my code, like hello and the address. And this gives you the possibility to try different combinations and maybe finding a bug in your code easily by using the log. So it's super useful.
In mathematics,
the other thing that is super powerful, that let me show you in the documentation, is that you can define, in our example, we define an entity, a super simple entity, like it was the account with a couple of attributes, but you can define entities with relationships. Let me look for an example of that because it's interesting here. You can define relationships, right? Like, let's say you have transactions and transaction receipts. You could define like these two things as entities, and you can link them by saying that transaction has a transaction receipt, and you are linking the receipt from the transaction. Okay, so when you query that in the playground, and by using GraphQL, you will see that these two things are linked. Okay, you can define one-to-many relationships too. You can do reverse lookups. This is something that you maybe, if you use ORM's database in the past, this is like a pattern very used in ORMs, like, I know, IChemy in Python or others. You can define a relationship, and then from a different entity, look back to the balances in this case. You can define many-to-many relationships to make it performant. This approach is very similar to what you do in a database by having an intermediate relationship to link users and organizations. So as you can see, there are many patterns you can use. I don't think I will have the time to give like everything because there's a lot of documentation, but I want to give you the tools so you can like bootstrap your subgraph, and then you can basically have the means to investigate and maybe adding and making them more complex. If I were to learn how to create a subgraph, I think that I will base with this documentation, and there are a bunch of examples online from big projects. Let me see if I can find for instance, Uniswap. Uniswap has a subgraph defining their. I'm referring to Uniswap because one of the biggest projects out there has their subgraph, and it's quite complete. So you can look for ideas. You can see they define their own helpers. You can base on other project helpers too. They have this function where they are defining handlers for tracking new pairs and creating entities related to that. If you're looking at a new project, maybe it's a good idea to look at the mappings file that I showed you initially, because this is the way you track everything. You can see how they link contracts to particular events, particular functions they use to handle the event. Okay. Also the schema file. This is a much more complete example than I show. They have these factories, token, a pair with these entities that can be linked, as I show you, with derived from, and one entity having other entity defined, like liquidity position has a user and a pair, for instance. So there are many options for you to play in your project, and I would like see other subgraphs from the other projects to get good ideas. Another tool I would like to show you is in the Explorer. Any questions so far?
Yeah, there are a few in the chat, and then one I pulled over from YouTube. If we want to go through them quick.
Okay.
I can read them to you, or if you'd like to read them yourself.
I'm not in. Are them in Zoom or?
Yeah, in Zoom. Yeah, I'll just read them out. The first one is just a general question about what Graph protocol does, and I'll just read it. So this protocol would allow us to index and search for data across blockchains on top of other protocols. Is that right? What about oracles?
Something that exists, Subgraph is now indexing things that exist in a blockchain. So if that information is put into a transaction that can be read, it can be indexed. So let's say Chainlink is the Chainlink project. There are multiple nodes in the Chainlink project that are submitting information on chain about different things, right? Like they're a solution for oracles bringing information from the real world to the blockchain. So you can set up a subgraph that is watching these contracts, and you could index the information that these contracts are bringing. Okay, so you could index Chainlink. You could index any information that is on the blockchain with the graph.
Yeah, one way to summarize it, and tell me if this makes sense, is the graph is good for indexing historic data, and oracles bring new data on chain. That's the difference.
Exactly. Yeah.
Cool. Let's see what the next one is. Raphael asks, is load an inherited method from the entity prototype? This is going back a few minutes, I think when you were going through the demo.
What's the question?
Sorry, I mushed that together. The question is load an inherited method from the entity prototype? Yeah.
It's every entity we define in schema GraphQL. It's extending the entity object. Yeah. So we don't need to define load. Load it's in every entity.
Okay, cool. Raphael, if that answered your question or not, just drop it in the chat, and then we can address it later. One of the questions from YouTube is, not very familiar with GraphQL, but what are the advantages of using Graph versus doing the same thing in MongoDB?
Well, what gives you GraphQL, it's super extensible. It's easy to query like different, it's a combination of two things. You define an entity format, but it's building an API for you almost automatically, okay? But by reading the entities that you define. So we thought it was a perfect solution to create a generic API that can be used for multiple use cases. If you were to, Mongo is a storage solution. Okay, for querying, you need something else. You can use the language provided by Mongo, basically when you connect on the client, but it's a different abstraction. The GraphQL lets you create queries, and then the storage can be something else. In our case, Graph nodes use Postgres. So this information is converted into tables, and like the storage is completely different. And you could swap the storage to something else, to something different to Postgres. But you keep GraphQL as an outer interface to the world.
Cool. Maybe this next question might be a little bit out of scope for this tutorial, but Raphael asks, will we ever get charged for deploying a subgraph?
The hosted service now is free. You can basically deploy subgraphs and using your project for free. What the new thing in the graph is that we launch a decentralized network in December. That means like instead of us hosting all the subgraphs, we have a network of now more than 100 indexers that can that they index subgraphs from the network. Okay, and dApps can use them. To use the network, you need to use GRT. There is a token, and we are planning some migration from the hosted service to the network, but it's going to take some time, and we will like give more information about how that will happen. The idea is to maintain the playground in the hosted service, but we'll provide more information in the coming weeks, we'll say. Okay.
I have a question.
Yeah.
Forgive me if this is like a dumb question, but I was just curious. I mean, it seems like a lot of these DApp protocols have their own tokens, but what prevents you guys from not using Ether? And then just why do you need a separate token? I was just curious on that.
Yeah, there are a couple of things, or I would say crypto economic mechanisms that we wanted to use. One is these are this token that we created have multiple functions in the network. There are like delegators, indexers, curators, and consumers, basically people that consumers, people that query the subgraph, and developers of subgraphs. So by having a token, we could like create more of a crypto. We are more like free to create crypto economic designs on top of this token. Indexers can stake, delegators can share some capital to indexers by using the token. We can have an inflationary rewards for indexers by minting an amount of tokens based on them providing service to the subgraphs that they curate. So if we're using it, we won't be able to add all these crypto economic mechanisms, or maybe we should have designed them in a different way. So that's the main advantage. I think that we can do like a complete call about the decentralized network because there's a bunch of things in the design. And it's very interesting. I would like to talk about that maybe in a different workshop.
All right, thanks.
Thank you.
Yeah, that's it for questions now, unless somebody just thought of one, but you can move back into whatever part of the workshop you were in, Ariel.
Yeah, I wanted to show this Explorer where you can, as I mentioned before, looking at open source code is a good way to learn and to get ideas for your project and to basically get to a higher level of I learn a lot as a developer by looking at other projects. So you can you have this Explorer where you can see subgraph created from the community. You see like many of the biggest projects in the ecosystem using it. So you can click on these featured ones and look at the subgraph. And a good thing to see apart from the code in GitHub is how they design the entities. Like basically designing the entities is like thinking about the tables and the relationship you should have in your backend. So is it a good idea to have a user? Do you want to, I mean, this all depends on how you are going to query the information. Is it a good idea to have a user? Do you have a pair in this case? They have a pools and they have pairs. So it's like probably they are like consolidating a lot of information in this entity. But I will look at the design of other projects for their backends. So I think it will help you to design your own schema. Because maybe that's one of the first things you will learn to do, like design the schema and then see how you map the events that you can read from a contract to this schema. Okay. Then you can play with the playground of basically any subgraph. You can query multiple entities at the same time, so like you can see in this example, but you can play and like, I don't know, this Uniswap factories entity has these attributes. You can add them like I'm doing now. Most liquid tokens. This is another entity that probably has more attributes. So you can query them like this. Yeah, so I invite you to play with the Explorer, see what other projects are doing, work on your entities, and start the skeleton as I show with the graph in it, and then deploy subgraphs in the Explorer and play with that. I think this gives you a good overview to start, but I would like to see if you have any questions, or maybe I went too fast on a couple of things and you want to me to repeat something, or let me know.
That's for you, hackers. If you had any questions or missed something while the tutorial was being gone through, now's your time to ask away. Sounds like you covered everything.
Okay.
Good job.
Great. If you, yeah, if I had a feeling I went too fast in a couple of places, but there's a lot of things to show. So yeah, the summary is like you have the tools and you can like now deep dive into the documentation and look at the examples of graphs. I will push the one I've been using in this demo, and I'm free if you want to ask questions after the workshop. Okay.
Yeah, it looks like one just came in from YouTube, not really related to the hackathon, I don't think, but will creating useful subgraphs help me earn GRT? I am very interested in being involved. I think that is true, right? There's some curation benefits. Yeah,
if you create subgraphs, you can do curation on the subgraphs, and by curating a subgraph, what you get is rewards from query fees that the indexers are that are using that subgraph are earning. Okay, so let's say 10% of the query fees goes to curators, and the curators are related to the process of creating a subgraph. So as a developer, you will probably, instead of pushing to the hosted service like I show here, you will be curating on a subgraph and pushing the code there. Okay, so you'll get rewards by doing that. There's a section in the documentation that this is split now, that you go to hosted service. This is the thing I show you, but there's a section for the network. We are completing this section, but you can see the roles I mentioned in all the crypto economics of the network, and the things you can get by participating, by being each of these roles, as a delegator, as an indexer, as a curator, and some guides. We are going to complete this document with more information about the network. Okay.
Yeah, another person asked, can you implement the graph in an existing project?
Yeah. As I mentioned before, when we started Decentraland, it was we started this project with the naive solution of querying the contracts. It was super slow. Then we switched to our own indexer, and then we switched to the graph. So the approach to implement something like that is you keep your backend while you develop a subgraph to replace that backend. You can test it using the Explorer and all the tools we have, and then you switch your front end to use the Graphql interface from the subgraph. now you know that the front end is working properly, you can like ditch your indexer if you had something for your backend.
One last thing, what would be the best tutorial to start with if you didn't know anything about Graph?
The best tutorial is this documentation I showed. I think it's pretty well written. There's all the things I mentioned, like from installing the CLI to what is a subgraph, the manifest, the schema. I will start by reading this and then basically running graph in it and getting the skeleton and step by step trying to implement something easy and getting it more complex with time. But yeah. And then as you move forward, looking at other projects, like bigger projects, and get ideas, like the Uniswap that I show, but there are so many in GitHub.
Definitely. Yeah, so I just dropped the link in there for thegraph.com/docs. Seems like a good place to start.
Thank you.
I think we've covered all the questions unless there's one. Oh, here we go. Let's see. Can you give a rundown on the other big projects in crypto doing data indexing, querying, and what the differences are, e.g. Dune Analytics versus the Graph versus whatever you think is worth mentioning? Well, Dune is not a protocol. Yeah. Like, well, yeah, sure. I'll let you answer. Go ahead.
Yeah. No, the ones I follow, I know from the communities, Dune Analytics, Nansen, maybe. They have maybe different approaches. The Dune Analytics they have a repo. I would say like a lot of information that you can query from different places to create charts and to create like some visualizations. And I think that they are very good at all these. I would say data science. And maybe the approach for the graph is like, even if you can do that with subgraphs, it's more of people are using more for as a live backend for the open data. Like you have some service running. Like a critical part of your application is, it's not that you are doing only analytics. We have sites like uniswap.info, but you have a running site. Like it's the backend for your dApp in a way, and that's the value. And you can aggregate information from different places. So I think that there are different approaches, and people tend to use maybe Dune Analytics for other purposes, like analytics that you do with some time. It's not at the backend for your service. Nansen is the same thing. It's more of a user oriented that you want to like track the token flow or other things. But it's not these services are not backend for Web3 applications.
Yeah, that's a good way to summarize it. Another question is, can you explain a little more about the cost in GRT we need to pay to deploy or query subgraphs?
Yeah, it's an interesting question. The indexers now, they set the costs by using a tool that lets them set the cost per query. And there's another entity that is a gateway that has like some indexing routing logic based on the query fees, but the query price. But maybe it's a bit soon to answer that question, because we are starting to see the market, the formation of a market around the query fees. So it's a bit early, because we launched like the decentralized network maybe a month ago. Yeah. So it's early. I will have a better answer after some time and see how indexers set up their prices. But I will expect competition. We have like more than 100 indexers already. So we'll see how this plays.
Good. Yeah. Okay. The questions keep coming in. Somebody asked if you can share the example code, and I believe you said you're going to push this as a to the repo.
I will push the example code. Basically, the example is indexing the graph token ERC20 and saving some information in an entity that you can query. You can use it for a different ERC20 if you want.
Another question is, could a subgraph be used to make a block explorer? What are the limits on subgraph size?
You can basically you can track. Let me show you something. We have my example application was using event handlers. So you set up this signature, and then you basically set up the function that you want to index. But there's other things called block handlers. Okay, so you can set up that you want to watch every block. Okay, and you have a handle block function. So you could basically by using that, you could like listen every block. You could store blocks and transactions. And by doing that, you have a block explorer. You have the I would say what you need to build a block explorer. Maybe it will take some time to index that subgraph, but you have the tools. So I would say the answer is yes, by using these tools. People typically use this subgraph to create like a backend for a specific application. Maybe a block explorer is something more general, but you could use these tools. Yeah. There was another question about that.
Other questions, not necessarily about the block explorer. What are the limits on subgraph size? Yeah, I think you answered that.
I didn't answer that, but we have very large subgraphs in the hosted service. I won't talk about a limit because I don't know if we set a limit. I can ask people in the team if we have a hard limit, but we have really large gigabyte, like many gigs size subgraphs.
I think I saw somebody syncing it was either an Ether or a wrapped Ether subgraph, and it seemed like it took quite a long time. So it's possible to do large ones, whatever
it's
that
possible,
ends up
yeah.
being. I'll try to find the tweet. Is Dennison.
Okay.
Let's see. Gawain asks, will the graph be compatible with Matic before the end of the hackathon? The end of the hackathon is February 7th, I believe. What do you think, Ariel?
I can ask the team. I know that we are doing some integration with Matic, but it's more of I need to ask the engineering team because they know better. We can provide the answer after the call.
Yeah. Gawain, I would assume it's not going to be, because even if it's available in like a week or so, it may not be enough time. So don't plan your project around this specific integration. But hopefully they get it in time.
Yeah, I think it's a good advice. If you are like waiting till the last minute to get that and create that dependency, I'm not sure about times, but it's a good advice if you can like maybe work around that.
Another question from Keita is, could I obtain a list of accounts who hold a certain ERC20 using the graph?
Accounts that hold a specific ERC20, you would need to maybe track all the ERC20s and see when there's a transfer to that account. Maybe I can think of a better approach to that. But there's a way to create, or maybe you can scan transactions and and see if the from or to address is related to that account. I would need to think about that, but I think you should you would be able. There's something that I didn't show, that it's data sources templates. This is something useful. Is if you want to track multiple ERC20s instead of one, like I did in the demo, you can create a template, okay? And then by setting up a template, you can then apply this template to multiple ERC20s. So you define how to track a transfer, let's say, for a contract, and then you apply it to multiple addresses that are using the same interface, ERC20s, for instance, okay? So you can create a list of multiple ERC20s I want to follow. So that's interesting. You can dive in the documentation and look for data sources templates.
Kata, did that answer your question? Or maybe we can talk more offline. Yeah, okay, cool. I think we've covered everything. After the last call, this is the last call for questions. If anybody wants to. Okay, we got another one coming in. What is the vision for the graph? I hear it is the new Google in a sense. Can you elaborate?
Yeah, it's the vision is to be a decentralized protocol for indexing and querying open data, basically. And we are focusing maybe the graph is popular for Ethereum because the project started by indexing the Ethereum blockchain, but it is to index any kind of information out there that can be like ingested, like the Ethereum blockchain. We are supporting other blockchains too, and create this mapping of the world by having a lot of subgraphs for different things. And that's maybe why people say it resembles Google indexing web pages, and we are doing this for like Web3. I see that resembles the resemblance is by the indexing, but that's the vision. So we are doing a great job by being the backend for multiple of the Web3 ecosystem, and we want to like keep on like integrating more chains, and we are doing that. When I show you graph init, it's not only supporting mainnet. There are like other things, XDAI, and we are planning to have more integration. So that's the vision.
I think that's probably a good place to wrap it. The graph has a huge vision, and they'd love to help you build that vision at this hackathon. Thanks, Ariel, for sharing this tutorial. If there's anything that needs to be followed up, we'll be in the Discord. I'm not sure if you're there, but it'd be great to have you join, Ariel, and then hackers can pass along anything or any roadblocks they hit. Yeah. Thank you, everybody, for sticking around.
Thank you. I'll join Discord and see you there.
Yeah.
Bye.
See ya.